Welcome, everyone. I'm Jana Foster. I'm the Engagement Manager for Maricus. I'm just going to quickly go through our agenda for this afternoon, and then we'll go ahead and get started. First, we've got Maricus introduction being done by Emily Davenport, Maricus's Engagement Manager. I'm sorry, Communications Manager. And then we've got uh, Tina doing our water level waves and webcams network overview. And she's Maricus's water level manager. And then we have Dr. Philip Orton from Stevens Institute of Technology doing the New Jersey and New York focused WWW network overview. And then we'll have a question and answer session. And then Sherry Schwartz from Tetra Tech will be doing a demonstration of OceansMap Insights, and we'll be gathering some feedback from everyone. So we will go ahead and get started with Emily Davenport.
Thanks, Jana. Hi, everybody. Thank you so much for attending today's webinar. And I'm just going to give you a quick overview of Maricus before we dive into our speaker lineup for today. So Maricus is a nonprofit organization and one of 11 regional associations that makes up the U.S. Integrated Ocean Observing System, or IOOS. And we serve the Mid-Atlantic region, which covers 10 states ranging from Cape Cod, Maine to Cape Hatteras, North Carolina. And this region includes 5 major estuaries, including the Chesapeake Bay, and supports a population of over 78 million people. And the Mid-Atlantic is rich in ocean and coastal data, and Maricus's job is to make that data available to be turned into usable information that supports safe navigation, emergency response, environmental health, resource management, and economic planning, among other things. So we collect and serve our own near real-time observations while also integrating data from state and local agencies, universities, and other partners. And these community and institutional collaborations are essential to understanding and responding to the unique needs of the Mid-Atlantic. All of our data are federally certified and meet rigorous standards that ensure the quality and reliability required for high-level decision-making at local, state, and national levels. And our suite of tools, which includes the OceansMap data portal, is robust, user-friendly, and highly customizable. And later on in our webinar, Sherry from Tetra Tech will be demonstrating how some of these features are tailored to meet specific needs across the region. Next slide, Jana, please. So Maricus is a stakeholder-driven organization that's built on a network of community partners and local experts. This allows us to stay closely connected to the regional and local priorities of the Mid-Atlantic and ensures our efforts are responsive, relevant, and grounded in real-world needs. Rather than duplicating efforts, we focus on amplifying the work that's already happening across the region. Our goal is to deliver the highest quality ocean and coastal data to support effective, informed decision-making. And we organize our work around 5 focus areas that reflect the full range of needs across the Mid-Atlantic. And you can see them on this slide. They're coastal hazards, maritime safety and commerce, fisheries and natural resources, water quality, and energy. And today we'll be specifically highlighting our water level initiative with a focus on efforts in New York and New Jersey. So if you have any data to share or are interested in partnering with us, we'd love to hear from you. And you can reach us anytime. Best way would be to email us at info@maricus.org. And you can also visit our website, maricus.org. And with that, I'm going to turn it over to Tina, who is our water level manager, and she's going to give you an overview of the Wave Water Level and Webcam project.
Thanks, Emily. Can you see my screen okay?
Yes.
Awesome. Sweet. Well, hi, everyone. My name is Tina Sepulpore, and I am the Water Level Project Manager here at Maricus, and I appreciate you guys being here with us today. So before we get into the New Jersey specific work, I want to give you a quick overview of the broader regional effort that's going on here in the Mid-Atlantic. Okay, so to start off, coastal communities in the Mid-Atlantic are facing more frequent and severe flooding. This can be anything from sunny day tidal flooding to storm surge and compound events, which is getting harder for local officials and planners to respond effectively. So what keeps coming up in conversation is that there needs to be better real-time data and a more connected cross-state approach. And this project is helping make that happen through sensor deployments and hydrodynamic modeling. So we call this the Waves Water Level and Webcams project, or the 3Ws for short. So while this is part of a broader national effort led by IUs, today we're highlighting the work happening here in the Mid-Atlantic. This project is a collaborative effort across 5 states supported by the Inflation Reduction Act that's helping coastal communities access the data that they need to better prepare for flooding and build long-term readiness. So this effort includes deploying low-cost water level sensors, wave buoys, ADCPs, webcams, and building hydrodynamic models to better track and forecast coastal flooding. So the data we collect feeds directly into tools used by emergency managers and planners, helping communities better prepare for things like storm surge, sunny day flooding, and wave impacts. And one of our goals is to make sure this data doesn't just stay local. So we're working with other regional associations to align this data with national standards so it can be used in federal platforms like co-ops, and eventually feed into NOAA and National Weather Service tools. So in the end, these efforts will improve real-time awareness and support long-term resilience planning across the region. So we've been working closely with the Weather Forecast Office to improve local modeling and forecast by sharing the data we're collecting through this network. But this isn't just about getting that data out, it's about building a two-way conversation with communities. So we want to hear from you and know what kind of data would be most useful in your day-to-day work or planning. And then really, this first year is all about listening and learning. So where are these data gaps located? What's missing that would help respond to flooding events better? So we're also making sure that we include different perspectives by connecting with tribal, local, and regional partners, because in the end, every community has different needs and priorities. So we have a customizable data platform called OceansMap that Sherry will talk more about shortly. But we want to know, what would you like to see on it and how would it be most useful to you? Again, this is a collaborative project and the input we get from you directly shapes the tools we're building, and that would be most helpful for you and your communities. So we're partnering with University of Delaware, University of Maryland, Stevens Institute of Technology, Monmouth University, and Virginia Institute of Marine Science to enhance monitoring across the Mid-Atlantic. And although each state is tailoring their approach to meet local needs, in the end, we're all sharing common goals, such as improving flood forecasting and early warning, supporting community readiness and adaptation, and integrating this data into national and regional tools such as OceansMap. So now that I've given you a bit of an overview, I'm going to briefly talk about what our other partners are doing in other states. So the first one is University of Delaware. This project is ran by Dr. Jack Paleo and Dr. Alexandra Schuler. So their goal with this project is to assess local communities with coastal process understanding and provide real-time knowledge for data dashboard use and install a wave buoy network for offshore modeling and forecast. So on the map, you can see that there's some red dots. Those are the proposed 7 SOFAR buoys that we're planning on putting out that would give us hourly updates. There is still some ongoing engagement to figure out where they want to put the water level sensors. Next up is University of Maryland. So the PI for this is Dr. Tim Canty. This project is part of the university's HydroNet and climate resilience network that built on University of Maryland's Grand Challenges work that started as a pilot program. So they were testing sensors in Annapolis and talking to local partners around Maryland. So the goal for this project is to expand the low-cost water level sensor network in Maryland and around the Chesapeake Bay. So they're focused on data deserts, which are areas along the Chesapeake that don't have any real-time sensors of any kind, better yet, water level sensors. So they've currently deployed 10 HOHO new sensors on the eastern shore, and they're currently looking at other sensors to deploy throughout other parts of Maryland. So with this project, there is still ongoing engagement to determine these locations with the highest need for these sensors. Last but not least, the project in Virginia is led by Dr. Derek Loftus. He's at the Virginia Institute of Marine Science, and this part of the project is focused on the southern Chesapeake Bay, especially around the Hampton Roads area. So the areas he's dealing with, people there regularly deal with flooding, but they don't have enough water level sensors in place to monitor it effectively. So a big focus is on supporting rural coastal communities that fall between more urban population centers. So these communities often don't have the resources to install or maintain sensors on their own. So this project would be a huge help for them. So every year they're focusing on different parts of the coast. So we have the Middle Peninsula, Hampton Roads, Eastern Shore, Northern Neck, and the James River. And they're going to be deploying two types of sensors. So they're looking at ultrasonic sonar and K-band radar sensors. They're also collaborating with the USGS and planning on deploying AI machine learning cameras in year 2 and 4 that can estimate water levels by analyzing videos. So all this data they get feed into a tool called TideWatch, which is a 36-hour storm tide forecast model that helps validate and predict where these flooding is happening. And since some of these areas don't have sensors yet, they're also bringing in the community science side by encouraging people to report local flooding through mobile apps. So this kind of input will help decide where those new sensors should go, especially in spots where both the model and residents can confirm that flooding is happening. So in total, they plan to install about 20 water level sensors across coastal Virginia over the next few years. And again, these exact locations are going to be prioritized based on flood risk, data gaps, and community input. And to kind of wrap this up, this regional network of sensors combined with like OceansMap is giving communities the tools they need to understand and respond to these changes. We're very proud to support this work, and we're excited to see what happens in the next few years with this project. And with that, I'll go ahead and pass things over to Dr. Philip Orton. So Philip is a research associate professor of ocean engineering at the Stevens Institute of Technology in Hoboken, New Jersey. He is a physical oceanographer that specializes in coastal physical oceanography, storm surges, flood risk assessment, air-sea interaction, and coastal engineering. He has authored over 60 peer-reviewed papers, contributed to the New York Times Sunday edition, and has served on climate panels for New York, New Jersey, and the IPCC. So I will let him take it over from here and share more about what's happening with his work here in New Jersey.
Thank you, Tina. And nice to see some familiar faces on the line out there. All right, let's go. My collaborators on this are Laura Kerr and Tom Harrington, who's also on the call. Observing and forecasting coastal flooding in New York and New Jersey. I'll also talk about wave measurements that are planned in the future with some of the new Maricruz related funding. The overall plan is to just give some motivation for improved observation systems for flooding, talk about this existing Stevens Flood Advisory System, a survey that we conducted on its users that really informs the benefits of this work, the benefits of using flood cameras for observation that were funded by Maricruz, which include evidence of flooding, validation of our flood models and forecasts, quantification of flood area, via image segmentation, AI methods, supporting machine learning modeling for flood nowcasting, meaning for the next few hours, aka flash flooding, etc., from rain and coastal sources. I'll talk about the plans for a new project funded by Maricus for the New Jersey's northern coastal bays from Atlantic City up to the very northern part of the coastal back barrier bays at Bayhead. And lastly, I'll talk about where we are in our research and what conclusions we can draw from it. So as everyone knows, the frequency of high tide flooding is rising. This picture is actually sunny day flooding from a flooding event I went to in Hamilton Beach, New York City, a place where, as of 2020, there were about 50 floods per year, certainly approaching 100 floods per year of that magnitude, or just below that magnitude, where it just starts to creep into the neighborhood. That's actually just exceeding, it's not a minor flood yet at that point. There's about 20 minor floods per year at that location, but there's an intersection into the neighborhood, critical intersection, that begins flooding about the same time as this location, which, like I said, happening almost 100 times per year now. And many drivers cause coastal flooding. It could be the river flow, the pluvial forcing, the rainfall, or it can be the tides and storm surge. In the past, we've only observed the water levels in rivers and tide gauges and estuaries and the ocean, and those aren't even really flood observations, they're water level observations. So we have metrics of what water level exceedance leads to flooding, and that's what the last figure was informed by, that flood threshold, or one really that I observed myself by being there. So there's many sources of flooding, and there's also compounding of the different sources. There's also groundwater emergence in some places also. So understanding coastal flooding really will require more data in new places, and that's been a realization, and there's many different scientists working on broadening our perspective on coastal flooding using different sensor approaches, like I'll talk about today. Some background, and I noticed Alan Blumberg's on the line and Tom Harrington. They're part of the past team that developed forecasting at Stevens. It's gone on for 20 years now. The current system is called the Stevens Flood Advisory System. It provides coastal water level forecasts plus an uncertainty range, a 90% confidence interval in a time series format that I'll show in the next slide. And that includes river effects and coastal tidal and storm surge effects, but it doesn't include pluvial sources of flooding, so that's one shortcoming. And it sends emails for flood watches and advisories out to 4 days, same day advisories or warnings, essentially the same day as flooding is expected, but also 4 days in advance as a flood watch to get people's attention. And that's for the whole region, but predominantly New Jersey, New York, where there's the most observations. And it just provides forecasts at the observation stations, at the tide gauges. It doesn't provide actual flood forecasts. It provides flood water levels, and then relative to the thresholds that it can trigger warnings that are sent out to people via email. And so we use the National Weather Service thresholds, the forecast water level shown in magenta, the observations are shown as red dots in the past, and that 90% confidence interval shown as the gray shaded area. So, I mean, one thing we know, especially after storms battering our region like Sandy and Irene in the past 15 years and other storms, is that giving one central forecast, also known as a deterministic forecast, is not as useful as giving a range of predictions or a confidence interval, or even letting someone tap into the probability of flooding at their particular location. So this is just shows a confidence interval around the prediction in the system. And we have assessed this system increasingly. Nikitas Georgios was a major developer of the system. He's now with Tetra Tech RPS. Mahmoud Ayad published a paper in 2022 on Isaias, assessing the system and its performance. And then now we have a manuscript submitted to Journal of Geophysical Research with Nikitas and others involved, assessing the system over 2 years of its performance to give a real probabilistic assessment of the spread, the uncertainty estimates, and the central forecast. And another thing we did about a year ago, we conducted a survey of the existing about 1,500 users that receive our emails. We had responses from over 20%, 351 respondees, And a very large response, I didn't expect it, comes from the New Jersey Back Bay regions, and where we actually don't feel we have our most accurate forecasts. And some of the users said, your forecasts aren't as accurate as we'd like, but they're the only game in town because there is not forecasting from NOAA on the backside of the barrier islands in these narrow, these back bays that are fronted by very narrow inlets. They're not resolved well by the NOAA models at present. And so we're the only forecast they have, and they find it useful, and they learn how to use, they can learn its biases and its, where it's useful and where it's not. And a lot of users are on Long Beach Island and locations like that. What we did learn that was really positive was what people use these forecasts for. The government users, and people could designate whether or not they're government, company user, or household user, essentially. The common response activities from government were moving vehicles to higher elevation, closing roads, emergency management activities, closing tide gates and storm surge barriers. We know at Stamford, Connecticut, and on the bay shore of Raritan Bay, New Jersey, there's barriers where they do consult our forecasts, and it helps them decide when to close their barriers. And a majority of the respondents were household users, who about half of which said they're flooded several times per year or more. Common response activities, again, moving cars, adjusting their schedule, applying flood protections to the home. And one thing that we've concluded from this is that this is enabling people to live with the water. There's a lot of people eager to use this kind of information because they're being flooded so frequently, and it helps them to live in the community they want to remain in for longer, dealing with up to 1 foot of water and chronic flooding. So how do we make these flood forecasts more usable by society to motivate our observation improvements that we're doing? You make them apply to the locations where people are. Instead of a gauge somewhere on a waterway nearby, you give them a map instead of a water level number with a vertical datum associated with it that only experts tend to understand. And you make them more accurate, and also without using vague terminology like minor flood or moderate flood. You show them a map. You make them more accurate, and you include all water sources, including rainfall, because water, for the most part, water's water. Salt water can cause more damage, but to a resident, whether or not they get flooded in their house is all that matters. And these are the goals of our work with the Maricruz funding. So we've deployed cameras. They're off-the-shelf cameras from Railink in the case I'm using. These are 2 out of the 3 cases we've deployed so far. This is from March 2025, a day with heavy rain. On the left is Hoboken Terminal location, now actually under construction for raising that parking lot by 3 feet. So I'm already located found another location in Hoboken to put a camera that's pretty flood prone, but that's a location that floods about 100 times per year presently. And then on the right is Camden, New Jersey, a location in collaboration with Drexel, Franco Montalto, where they have ultrasonic sensors looking at flood depth on the street. This can be very complementary. There's widespread network. There's a network in New York City called FloodNet, which is deploying hundreds of sensors around New York City. Those ultrasonic sensors just measure flooding at one point using a time of flight for the echo to return. But these cameras can be very complementary. That's one thing we're studying, is the complementarity of these different sensor networks, because these cameras can make a spatial measurement, essentially, of flooding. Here we are in OceansMap. I think we'll talk more about this, but there's the 3 locations with deployments so far in OceansMap: Rockaway, Hoboken, and Camden. These are deployed with solar power, cellular communication. The little Railink cameras are shown here. And so here's you could actually see the view perspective in OceansMap of the camera view. And I'll mention that it's part of a broader network also. We're collaborating with Greg Dusek and Jeremy Cothran, who are behind Webcams and from the Sakura IUS team, and they definitely helped us along. And we also show our cameras in the Webcams network. They've been very helpful. So what are some applications of street flood camera observations? First, just telling the story of what's happening and understanding the problems that lead to flooding. This is a case where we get snapshots every 10 minutes through the system. I can turn on video, but we just automatically collect 10-minute snapshots. This is a snapshot where I've subsampled it every half hour. So it's about 2 hours of sampling. The top left one, there's a stormwater sewer and the water's just starting to emanate from it. It's got kind of a white coloring, reflected color to it. Then it spreads out a little bit by half an hour later. And then it's getting out onto the street and up onto the sidewalk an hour later, eventually crossing the street. There's multiple stormwater sewers that are, and the flooding from them is all merging together. There's a car driving through the water. So it tells the story very clearly that there was stormwater sewer backflow, which is something that the property owner had, where we have the camera mounted, a nonprofit has been complaining about, and the city hasn't solved over multiple years. But this is a particular day. This is a flood frequency of a high tide level that happens about 7 times per year, so not extremely unusual that this occurs at that location. So we can tell the story, provide evidence of the flooding. We're also working on image segmentation. Actually, we really didn't make as much progress as I'd like. It was sort of an add-on to the project with a grad student or a master's student working on it, and she's gone now. But we made a little bit of progress and learned the limitations of her, the techniques she was developing for image segmentation to identify the flood and eventually turn it into a flood area estimate and a flood map. But there's a lot of groups working on this, so this is definitely an area that will be seeing great improvement, and that'll be a tool that's used with these cameras to make the data more quantitative. And lastly, I have a PhD student who has a chapter who's about to defend, actually, Shima Kasei, who, with Kei John Liu, another professor with expertise in machine learning here at Stevens, developed a long-term, short-term memory model that outperforms bathtub modeling. So Russell on the left, Beach 84th on the center column, and Hoyt on the right column, transition from dominantly tidal flooding to compound flooding to rainfall-driven flooding. And the bathtub model gets worse and worse as you go toward more of a role for rainfall flooding, and it doesn't even perform that well to begin with when your tide gauge is pretty far away that you're bathtubbing from. It gives you a fairly bad prediction of the flood depths. And so the flood depths from the machine learning model, LSTM model, are much better across many metrics. So that research is submitted to a American Meteorological Society special journal issue and also the AGU 2025 meeting in New Orleans. And so what this could lead to, this is just a demonstration using hindcast data, which is more accurate than forecast data. But this was a 30-minute prediction into the future, and the performance was better at 10 minutes, and it was slightly declined at 30 minutes, but it was still fairly good. And so we imagine that this could be developed into a forecast system where people's phone buzzes them and it says, in 20 minutes or half an hour, you're going to have a foot of water. And based on radar and model-based nowcasting of rainfall, and I didn't mention this is based on rain data. The machine learning model is based on rain data and offshore water levels from our forecast system, actually, but as I said, in hindcast mode. So it enables us to extend our water level forecast system to be a flood forecast system that includes pluvial forcing in an urban environment. And we envision that could give people warnings of on the order of an hour in advance of flooding. All right, and the last thing I'll talk about is our new project, which is looking at New Jersey's northern coastal bays and looking at water level, flood forecasting, and wave observation and forecasting. So a special motivation here is these back bays, these back barrier estuaries, sometimes called lagoons, are areas that are very much understudied. Tide gauges historically have been located in harbors and ports and deeper water areas, and these systems have only been observed for about the past 20 to 25 years maximum by United States Geological Survey. I saw Chris Schubert was on the line. Thanks for your help with those measurements, Chris. And so there are areas that are understudied and under forecasted, but tide and wind-driven flooding are a more frequent problem than most of the harbors and ports, in part because a lot of property is low-lying, built on top of wetland landfill in the middle of the 20th century, and on top of tidal marshes. There's land subsidence. The tides are often fairly small in these back barrier estuaries, and so the storm surges are smaller, so the homes are not very high above typical high tide. So a foot of sea level rise over the past century is leading to chronic flooding in some of these areas. And so there's not much forecasting. Even Stevens flood forecast system, as I already acknowledged, has its some of its worst performance in the back barrier estuaries, and that's why we're looking to develop a new model for improved forecasting. Here's a few pictures of northern Barnegat Bay flooding and Mantoloking. The project goals are to provide critical information on water levels, waves, and flooding in these northern back barrier communities of the Jersey Shore from Atlantic City northward, apply an innovative combination of modeling, wave and water level observations, and street flood sensors and community engagement to develop tools that improve preparedness for flooding among these communities. The task areas include engaging communities to learn of their forecast needs, providing useful information to them. We've already learned from the New Jersey Sea Grant Consortium meeting last January that blowouts are another thing of interest to boaters. The water levels can get too low for passing certain areas when the winds are blowing water out of the bay. So it's not only about flooding and waves. Learning their specific needs. We will be intercomparing different wind wave measurement technologies. I'll show that on the next slide. Developing plans for operational coastal hazard products, seeking community input, setting up operational long-term observations using a SOFAR buoy, and finally determining the best water model for the above needs that we're learning about in year one. And over the next year, we'll be developing the models and evaluating them and validating them and tuning them against observations. And finally, operationalizing this improved modeling for the northern back barrier systems of New Jersey. And so far, the progress on this has been, we purchased an ADCP on departmental funding, actually. We purchased the SOFAR buoy on the Maracus funding. We're going to intercompare these measurements to learn sort of the limits of the SOFAR buoy in an environment that they haven't been used as much in, with very small waves and relatively shallow water, often less than 2 meters deep. We've begun conversations with NOAA, with Saeed Mokimi, to tap into their expertise and sort of the next generation modeling and forecasting system tools that they're using. Hoping to use Sphinx the schism model for capturing water hydrodynamics from deep ocean all the way up to rivers and creeks with one single mesh. We're also exploring using the Sphinx reduced physics model. It's a more simplistic, rapid model that may be valid to use in this system. We'll evaluate its accuracy, but we've been setting that up and because if it's faster, it may be easier to run a whole ensemble of different weather forecasts that enables us to better quantify uncertainty. And when you have the more complex models, it can be difficult to have the computational power to run these large ensemble predictions. And lastly, we've had initial engagement discussions with Bayhead, where we're planning on deploying a camera, Long Beach Township, and Atlantic City, where we also hope to deploy a camera. And those are some of our primary stakeholders so far. We've been learning and hearing a lot about how rainfall flooding is really important part of the problem. So that may influence to focus on capturing both the tidally driven and storm surge driven flooding and the rainfall flooding. So to conclude, street flood observations, including cameras, can contribute to societal flood mitigation and preparedness. They can complement or even be used to create forecasting systems, and lastly, coastal community flood resilience can be improved through combined engagement, flood and wave monitoring, and forecast systems. So I'm happy to answer any questions. I don't know if we're going to go to questions now, or I think we are, or take it later. Thank you.
All right, folks, and we will go ahead and allow for some time for questions for both Tina and Philip. Tina, one question I have for you is you talked about building two-way conversations. Can you give an example on how community input has already shaped decisions in this first year?
Yeah, so in Maryland, for example, Tim and his team are driving around, going to all these different locations, like to towns, counties, and having conversations with the communities and local partners to get an idea of where that first batch of sensors in the Eastern Shore should have gone. And another one is even in Virginia, just having the community feedback that plays a huge role in shaping where those sensors will be deployed. So, I mean, even though we're still in the early stages of this project, that kind of direct input is already making a difference. And it's exactly the kind of ongoing conversation we want to keep having, not just this first year, but throughout this project to see if it's not happening now, like later, where these sensors would be best for the communities.
Wonderful. Thank you. And then Philip, we've got a question for you in the chat. How far away are you from providing reliable forecasts of neighborhoods? And what is your vision for the right number of sensors?
Great question, Dave. Neighborhood inundation has been possible. It's been done. It's just a question of having the right models for Barnegat Bay and these other bays. You know, we'll have it within a few years under this project. We're certainly moving toward that, and it depends on how detailed of modeling we want to use. NOAA is moving toward using bathtub modeling of sorts for coastal flood inundation mapping, you know, flood forecast mapping. We can do that. We can also set up more complex models. So that's a key question, and this project is sort of one of our pilots for going in that direction of providing mapping instead of just water level predictions. What's the vision for the right number of sensors? That's a tough question. I mean, it's not for every single neighborhood, obviously. I think the models can take over at some point. If we're using that machine learning modeling technique, then it's developed around a sensor. And so a data-driven model requires a sensor. If we're using these water models, then they can be improved using the observations, but then they also have the detailed physics in them, in many cases, to create maps of flooding instead of water level prediction. I see a lot of questions popping up. So I see, is Ocean from Ellen Prager. Hi, Ellen, nice to see you. Is OceansMap going to be the dissemination tool for forecast and flooding info? That's a great question. We haven't talked about it yet. One thing we know we'll do is we'll wrap our forecast for Barnegat. We think we'll wrap it into our existing flood advisory system, and we'll have at the locations of tide gauges, we'll have those water level predictions as a time-dependent predictions into the future. But then it depends on, we could also have flood mapping in that system, and it's something we need to move our website toward, is flood forecast mapping. So I think it'll be there, and I think there's a good chance it'll also be part of OceansMap, but we haven't discussed that yet. And I'll keep going.
Yeah, you got another question from Dave in there as well.
Dave says, question 2. Phil, have you worked with NOAA's Coastal Modeling Division at VIMS to see their accuracy and plans for improved inundation modeling? So NOAA's Coastal Modeling Division at VIMS, I didn't know there was and I think you might mean the people at VIMS who are creating models that are used and operationalized by NOAA, Joseph Zhang and others. think, probably, but I'm not sure. To see their accuracy and plans for improving additional amount, definitely interacting with them, yeah. And I was on a seminar yesterday where Joseph Zhang was actually presenting, and it's a NOAA seminar series. So trying to interact more with them because they're really pushing the envelope at NOAA. They're doing great work. And also people at VIMS like Joseph. So aware of them, definitely. Ellen Prager asks, as an academic institution, how do you plan to transition from research to operations, which requires full-time monitoring, maintenance, to be sure it's operational full-time? Well, Stevens has had operational forecasting and observations for 25 years now, or so, at least 20 years. As I mentioned, the water level forecasting has existed for 20 years. And so it's something that we've been doing, but it is always a challenge. It's one of the things that Maricus has really come around at just the right time for me. You know, I've been engaging with Maricus, and the funding for Maricus is for this, right? It's for operational tools that are useful to society. But outside of Maricus, it can be difficult to get that kind of funding. NOAA tends to only fund studies that will operationalize usually within NOAA's own systems, which we haven't done previously. So it's hard to get, you know, it's nice to have a organization through IOS and Maricus that funds academics to also be developing these tools and educating the next generation of professionals. So that's our perspective on that. But it is a challenge. Alan Blumberg, who's one of the creators of SFAS and the NIHOP system, asks, he says, I like that you emphasize forecasting where people are. How do you plan to inform the public for these new forecasts? Great question. Anybody else want to pitch in? Certainly through social media, and that's one thing that Maricus specializes in. And we're engaging, like I said, with Atlantic City, Long Beach Island. There's already groups like Long Beach Island already has their emergency management tapped into our forecasts, and it helps them with their emergency management, the water level forecasts, however imperfect they currently are. So some of it's just remaining engaged with those communities, but between Atlantic City, Bay Head, Long Beach Township already, we're engaging with a lot. Often we engage with the experts in the emergency management, but we also hope that the website, to improve our web resources so that they're more, they have a simple upper layer where the average person could interact and get information. And maybe we'll develop apps, you know, and be putting the same things on apps just to get the data out even more widely. And another question from Dave Jones. He says, Phil, me again, smiley face. Have you thought about providing output from your forecast system as a web service so that other GIS systems can ingest and share the output? That's a great question. I've heard that NOAA's moving in that direction, and I think it's something we really need to think about. So very good point. Dave, feel free to reach out if you're with an organization that would let us use this kind of data. I think the data is meant to be public if it's funded through Maricus and NOAA, and there's no reason we couldn't do that. It might require more work or more effort, but it is definitely something we should work toward. And that's all the questions I see so far.
That is all the questions I see. Does anyone else have any other questions at this time? All right, well then I'm going to go ahead and introduce Sherry Schwartz, who will be giving a demonstration on OceansMap Insights. Sherry is our project manager and operations coordinator with Tetra Tech, and she works very closely with Maricus to have OceansMap running wonderfully all the time. Thank you, Sherry.
Thank you, Jana. Hi, everyone. As Jana said, I'm Sherry Schwartz, and I work at Tetra Tech Ocean Science. We are Maricus's data managers and have recently worked with the Maricus team to develop the OceansMap Insights. And we are continuously improving these. So let me go ahead and share my screen, and we can explore them a bit together. All right, you should be able to see my screen now. Now, the OceansMap Insights are pre-made permalinks to interactive maps and dashboards, and they were designed to provide quick and easy access to real-time data for a variety of scenarios and users. There are currently 22 insights, and they're organized into 5 categories that are shown at the top of the page here. So let's just go ahead and pick one to explore together. I already opened it in a new tab, but I'm going to explore this water temperature anomaly one. So this is the water temperature anomaly insight. And now for those of you who have never seen OceansMap before, I'll give you a really quick orientation. And when it first opens up, you'll of course see the map with some data visualizations and analyses, especially if you clicked on a permalink or an insight like this. Like most map-based portals, you can navigate by clicking and dragging the map. You can zoom, such as with the mouse on your wheel or your trackpad if you're using a laptop. We also have these zoom buttons down here as plus and minus buttons and a zoom to box selection in the top right. Alongside this tool on the top right, we also have a few other icons up here. And these are really helpful tools for sharing, collaborating, or gathering more information on your data layers. So this one right here is how you would generate a permalink. We call it share this view. And you would simply adjust your settings and create your URL, and then you could just save and share that URL with anyone, and they'll open up the exact same view. We also have a screenshot tool, a tool to generate animations of your data as it moves over, changes over time. The Activate Hover Tooltip option allows you to just hover over your data on the map and pull up just some data points really quickly at that location. You can also measure distances, and of course, you can open up your legend. And then over here on the left, we have a lot of icons that are just tools that are really helpful for exploring and analyzing your data. So this does include our catalog, which has the full list of all of the layers that are available on OceansMap, and they're all organized into these categories as well. We also have our virtual stations tool over here, weather window planning. You can run validation statistics. You could generate your own shapes and lines and virtual stations, of course, but like data, like points on the map if you want to draw a custom layer. You can change the base map. We're actually using compare mode, as you can see by this slider, so I'm going to circle back to this tool in a moment. And then we have a list of insights in here as well for quick access and a feedback form. So if you ever have questions, feedback, concerns, comments on OceansMap or the data that you're looking at, or if you just need help finding something, please feel free to use this form to reach out to us. The email will come to me as well as to the Maracus team. Okay, so now I'm going to pivot back to diving into this insight a little bit more deeply. And like I said, we are looking at compare mode. So let me open up that tool and take a deeper look. So I can see here we have our GOES sea surface temperature as well as our sea surface temperature anomaly both on the map. And in the compare mode tool, we can toggle the slider on and off with that toggle up there. And we can also determine how we want to differentiate on each side of the map, how we want our data to show. So for this one, we've got the sea surface temperature on the left and the anomaly on the right. If we wanted either layer to be across the entire map, we would see this, we would select the circle and then it changes blue like that. Okay, so now that I kind of can see what I'm looking at here, we do see in our legend this color palette. It's got the full spectrum for the left side of the map, and that's the temperature value. And then the anomaly on the right side is only showing, it's like a different color palette, right? It's just blue to red and going from -5 to 5. So what this one's telling us is if temperatures are lower than average, they're going to be that blue color. And if they're higher than average, they're going to be that red color. With compare mode, we could also, for example, if we wanted to zoom in on like a New York or New Jersey location that's close to this, relevant to this group, we could definitely do that. And then it's pretty easy to use the compare mode slider to just explore how that data changes on each side of the map. We could also set a virtual station by clicking somewhere on the map, and then we'll see our data points down here in this table. If we wanted to just save this, come back to it later and revisit this exact location, we could do that. So in order to get started, I would first want to add to my virtual stations. And as soon as I do that, we get a nice colored buoy, a label, and over here on the left, we see the virtual station has appeared. So coming into this tool, I can edit it. I can change the name, add a description, change the color. I can even change the location if I realize, you know what, I want to be a little over here. click save and it moves it, or you could just drop in GPS coordinates if you have those as well. You can create as many virtual stations as you need, so you can add more. You could even import your own CSV file and upload them that way. In order to come back to this, you do need to update that permalink. So I would just open up the Share This View tool once more and generate a new URL. So you do need to copy and save that new URL. The Insight link itself, such as like what's on the landing page, won't update just because you made some changes. Just keep that in mind. All right. Moving into the next insight. So this one we're going to look at is in a dashboard format, and this is the Boater Safety in Long Island Sound dashboard. So this one is designed to kind of just help boaters safely navigate through the sound by providing an in-depth understanding of current conditions. So right off the bat, we see a lot of important information. Up here at the top, we have these observation metrics that are coming from a co-ops buoy. We've got 1 minute water level, wind speed, and wind direction. We also have the valid time here so that you could see just how up to date that data is coming through. Right beneath that, we have a data table which has predicted values. So these are coming from models such as NWPS and the Syracuse water level model as well, just to help understand more predicted values of different types of data that's available. And these are all coming from the same location, which is this gold virtual station that I created on the Mini Oceans map. Now this takes me to the Mini Oceans map part of the dashboard, which is pretty cool. So it's a new feature, and it just allows us to basically embed OceansMap into the dashboard. So it shows some data layers are loaded on the map. I can open up my legend to take a look at those. We do have NDBC and co-op stations. We also have wave predictions, which are both, I think, about 50% opacity. That's why you can see them overlapping here. So you could see how those two different models agree or disagree. We also have water level predictions and then a lot of wave height and wave period as well, but those are all fully transparent. Now, because you can't just look at this and see all of the data layers at once, we do also have the Activate Hover tooltip. So you could just click on that, hover on a specific location and just give it 1 second, and it'll give you a really nice view of all that data and just a very quick snapshot, which is really cool. Okay, so scrolling down, we also see this weather window time series. Now this example is showing, it's going to show you green when conditions are ideal for boating and navigation. So that is when waves are below 3 feet and winds are less than 20 knots. Red displays when waves are greater than 7 feet or winds are above 40 knots, and yellow would display for values in between. So in this scenario, we can see that we have an entirely green time series, which means that conditions have been pretty good and are predicted to continue to be so through, or at least until the morning of August 1st. Scrolling down more below this, we have some additional prediction time series for some key metrics, including wave height and wave direction. We've got tides, predicted water temperature, and then of course rose plots at the bottom, which display some forecasted winds and currents. Now, like the map insights, the dashboards are also very easy to update for your needs and kind of adjust things as you need to, and then save a new permalink. For example, if you could change these thresholds in the weather window tool. And so I'll just show you how to do that. First, you want to click this unlock button, and then as soon as that's available, you can play with the dashboard in any way you want. You can kind of change the way the size and format, as well as clicking on these pencil icons to actually edit the settings for each widget. So if I were to click on this time series setting, I can see my thresholds and how they're set here. So I can always adjust those as needed for my needs. Just click the Save widget, and it'll update that in the widget as well. And then when you're done, you would just lock it and generate a new permalink. Before I do move on from this insight, I just want to mention this Mini OceansMap tool once more, because if you did want to either edit it or explore it, or just really explore the full functionality of OceansMap of this same view, you could basically, these Mini Oceans maps are generated through a permalink. So if you open the Edit Settings menu, you can grab that permalink and put it in a new tab, and it will automatically pull up everything that I had shown that we had available at the exact same view. So you could really dive into it and explore it, add your own virtual stations, add different layers, change whatever it is that's going to be most useful to you. You would, of course, need to save that new permalink from the map view, and then copy it, and paste it back into your settings here, save your widget, and then create a new permalink for your dashboard. So it was a little bit of a few steps there, but very, very flexible and very handy, which I think is pretty cool. All right, now I'm going to move on to our next insight. And this one is our East Coast storm tracking insight. So for this one, we're looking back at our map view, and we can see some data that's loaded right away that gives a high-level overview of storm-related information along the East Coast, especially. So I opened up my legend to take a look at what we have here. And we see that we have wind predictions from GFS winds, which are, of course, the barbs on the map. We've got gliders loaded. We have SDOF surge tide. That I know is at 0% 0% opacity right now, and I'll show you how to look for that as well. And then the global wave height is what we see as the color overlay on the map. We do also in this insight have an active storms layer from the National Hurricane Center, but we don't see those cones or anything like that on the map at the moment because there are no storms predicted out there for right now. Okay, so let me just take a look at the data layers. So one quick tip here is if you do look at this full catalog, it can be a lot. So if you click the active section or filter, it will filter out anything that's not currently active on your map. So it's really handy. You don't have to do as much scrolling. As I mentioned, I know that this one has been adjusted, but if you ever want to check or play with settings, you would just click that gear icon next to the layer name. And so this one is at 0% opacity. If you want to get more information about the layer, if you will need to access the actual data, you can do that by clicking the info icon, where we'll usually have a background abstract on that data set and access links as well. So this insight, we also have a virtual station preloaded here at Elizabeth City. So I'm just going to go ahead and zoom into that. And as soon as I click on that station, it's going to pull up some data from that location. But let's say we're maybe more interested in a location further north, and maybe we want to understand how the model data sets in this insight are comparing to observations or even another model. So first, I just wanted to kind of zoom in here closer to the New York, New Jersey area. And now I'm going to open up, let me close this. There we go. All right, now I'm going to open up our validation tool. And so once I'm in here, I can choose the parameter that I want to validate. And so in this case, I'm just going to go ahead and say wind speed. And then we have to pick a baseline. So the baseline could be another wind speed model, or it could be an observation station. So I can just click show available stations, and OceansMap will pop up with all the available stations that have current winds data that I can use to validate my model. So I found one that I knew was working. I'm going to go ahead and click on this one from Waretown. And then I just pick my comparison, which I want to use the same model. And once I've got that selected, all I need to do is click calculate, give it a moment, and it will generate a few bits of information for us to help us understand our validation here. So we'll get an error statistics table, a scatter plot showing observed data on the x-axis and model data on the y-axis, as well as a simple time series with both data sets showing the observations and predicted values over time. So you can really see where those sources aligned and when they differed. It's still loading those, so I'm going to give it a moment and I'm going to actually move on to the next one and we'll circle back. I think it'll be done loading by the time we come back. All right, so this is the last insight that I have to show you today. This one is a little bit more geared towards recreational users. This is what we refer to as our surfer's dashboard. It is perhaps a little more simple than the one that we looked at earlier, but I think that really shows the flexibility of the dashboards and insights and really just how they can be adapted to specific user groups or various needs. So as soon as it loads, once again, we have some real-time observation data up here at the top, nice and big and really handy to see, especially if you're on a phone. And then we also have our oceans map here as well. And this one is depicting winds, which are these white animated streamlines we see. We also have wave direction and wave period and wave height from the NWPS sources in the Chesapeake and the Philadelphia region as well. Scrolling down, we do have some time series as well. So these are showing the observed data from the past 48 hours as well as modeled predictions during that time, but also covering the next 48 hours for wind speed and wave height. We also show 2 time series for wave period and direction. And then over here on the bottom left, we have a rose plot for wave direction and period. And I think this was plus and minus 2 days as well. Before I wrap up, let me just go back here. Oh no, it generated an error. It worked earlier today. Okay, I think I'm going to go ahead and see if that loads, but for now, I'll wrap things up. I know that everything was a bit of a whirlwind, but I think that that's all we have time for today. Additionally, if you are curious about, or sorry, I was going to say, please don't hesitate to use that feedback form if you do have any suggestions or questions after today. But also, if you're curious about learning more about how to use any of these tools, or if you just want to learn more about any of the ones I didn't have time to cover today, you can find some really great tutorials on Maricuse's YouTube channel. Oh, look, it just finished loading. Awesome. So like I said, we've got our error statistics, our scatter plot, and our data comparison. So for example, if you wanted to know more about how to access or how to use this validation tool, you could go to the Maricuse YouTube channel, like I was saying, but these tools also have that eye icon at the top of them. And within that, we've got this really detailed kind of a cheat sheet on how to use the tool and what goes into it, as well as those videos embedded in here. So you can find them very easily. All right. Thank you very much. I'll hand this back over to the Maricuse team.
Thank you, Sherry. We actually have a couple of questions for you in the chat if you want to
Oh, sure.
pull those up. We've got one from Dave.
The question from Dave is asking about the period that the ghost temp anomaly is used to compare to average climatology baseline. I don't know the answer to that question. I don't know if there's anyone on this call who would, but I can definitely, it doesn't look like it. I can definitely find out and get back to you, Dave.
Awesome. Thank you, Sherry. And we've got two other questions in here. One is the idea that all the state water level data will be aggregated up into a regional layer in OceansMap? If so, and adding to Dave's previous question, would it be able to use that layer in our other GIS systems? And what sort of insights do you envision providing with this water level data? I think that,
So
go ahead, Sherry.
no, you can finish your thought.
I was just going to say, I think that in terms of the insights for the water level data, we're still really trying to build out those insights and get feedback on what would be helpful for different communities and stakeholders. And I think that's kind of one thing we can certainly gather feedback on and see what makes sense for us to build out in the future as all this water level data gets put into OceansMap over the next year or so. What are your thoughts, Sherry?
Yeah, I definitely agree. And with the webcams that we have on OceansMap as well, which I can share if we have some time afterward, but I think those would also be really useful in an insight, and we could, pair that with water level data and definitely I think a lot of different like flood monitoring or, different types of users that we could support with those insights, I think. In terms of the first questions, is the idea that all state water level data will be aggregated into a regional layer. I don't know if that's the plan, but I think that's definitely doable. So it's something we could work on if we were asked to. Um, and we'd be happy to take a look at that. If there's like data sources that you're thinking about and wanted to shoot my way, please don't hesitate to reach out. We can absolutely just poke around, take a look at what's available and see what it would take to put it into OceansMap. And I think for the second question, I'm guessing a little bit here, but I think we would be able to provide that in a way that it could be used in other GIS systems, but I would have to confirm that for sure too.
And then we've got one other question from Ellen, who is our attended audience for insights? And have you gotten much feedback from audience on usability? So, I mean, for our audience, I mean, I think it's pretty spread out. We're trying to make insights for different types of audiences and kind of target more that way, both regionally and for use cases, whether it's like recreational boating data or, beach data or storms. It just kind of, our audience is all over the place, and we're trying to create insights that will target different types of audiences. And we have not gotten much feedback on usability, but we would love to get feedback, and that's why we've got that feedback option on there. The more feedback, the better, and the more better that we can make things moving forward. So any feedback that anyone has, please send our way. Okay, awesome. Sure. Do you want to show real quick where the web camera data is pulling from an Oceans map right now?
Yeah, no problem. I already pulled it up.
Thank you very much.
I think you can see my screen now. So when you open up OceansMap, originally there will be a couple of default layers. If you want to turn those off, you can just click this eye icon and it turns everything that's active off. And then I just opened up the data catalog and we've got our categories. So we have one webcams category with the Webcams layer. As soon as you click on that, we've got those 3 locations that Philip was showing us earlier. And you can hover over these or click on the station and it's going to load that same preview. And if you click on it, it's going to pull it up even bigger for you as well. It'll have the date and the time. So, it's 2:37 p.m. right now, but the most recent time image we have is 1:52. You can also see the link to the actual Webcams page. So if you wanted to open that up, this is really handy. You can see, again, a map of not just where it is on the map, but also which direction it's pointed, which could be super helpful. I mean, there's a lot of archived 10-minute stills in here as well. Of course, you could also explore the time slider in OceansMap and go back to see older images as well. And so like Philip said, we've got 3 in here and they all work just the same. Yeah, that's basically it. Very simple. But like I said, I could definitely see these being in an insight with some flood data and just about, whatever else would be important. I think we could really come up with something powerful.
Yes, agreed. And I think that will be our plan as we move forward and all this data actually starts getting collected once things are deployed. Wonderful. Thank you very much, Sherry. Does anyone else have any questions or comments for Sherry or Dr. Philip Orton or Tina before we wrap up this afternoon? Wonderful. Well, I'm going to pass it over to Emily Davenport one last time for her to do just a little quick wrap up for us. Thank you very much, everyone, for attending.
Thanks, Jana, and thank you to everybody for tuning in. Before we sign off, I just wanted to remind you of a couple ways to stay connected with Maricus and keep up with all of our updates, projects, opportunities, etc. So of course, you can visit our website. I encourage you to go there and sign up for our newsletter for regular updates. And you can also follow us on social media and on YouTube as well. And what I'm going to do is I'm going to drop several links for you in the chat so you don't have to write anything down. You can just go there and please subscribe, follow, and contact us if you need anything from us at all. We really appreciate your time today.
All right. Thank you very much again, everyone, and hope you all have a lovely rest of your day.